definitely. Okay, so this is a quote you might have noticed, right? If you think that the internet has changed your life, think again, right? The IoT is about to change it all over again, right? So internet is just a beginning. If you have an IoT, okay, so that will still going to, you are going to still advance, right? Okay, your life is going to be enhanced. Okay, so whatever it may be. So these are the three things, okay, I want to show you. Okay, what is IoT, getting familiarity with IoT, what are the design aspects of IoT project. Of course, we'll see at the end of the session this one. So third thing is simulation. Okay, simulations. Okay, so these three things are the main basic agenda of today's session. Okay, so first of all, you just see this. Okay, directly we're going to the, rather than technical stuff. Okay, so this is a fridge, right? This is a refrigerator, right? So this is a, I want to make this a thing. Okay, so this is a thing. Okay, first of all, what is a thing? So anything besides a traditional computer, like uh, apart from your laptop, desktop, right? You may think of thing as anything, right? Refrigerator, AC, your smartphone, right? Or your chair. Okay, whatever it may be, your spectacles, your shoes, anything can be made as a thing. Okay, so first of all, we'll understand what is IoT in the context of this thing. Okay, so see this is a simple refrigerator. Okay, so first what I try to do, so rather than what is the purpose of refrigerator. Okay, so there is a to keep the things cool, right, at a, to maintain a temperature. Okay, so whatever it may be, so it has a basic purpose is there. Now what I do, I add a computational intelligence to improve the, okay, to improve the functionality of the device. So to this refrigerator, I can add a computational intelligence, right? So definitely how to add a computational intelligence to a thing, right? So like you have a brain, right? So already as a humans we have a brain, right? Now I want to add a some intelligence to the thing. Okay, what is the thing here? In this case, the thing is a refrigerator, right? So what is the purpose of adding this, that we'll see. Okay, what is the purpose of adding this? All these things we'll see, but just see this refrigerator is one thing. Okay, so to this thing I'm adding a computational intelligence. Okay, how I'm going to add this computational intelligence to this thing. Okay, so using some, okay, using something called a microcontroller. Okay, so this is a Arduino board. Okay, so you might have noticed Arduino, okay, the term. So this is one microcontroller based embedded board, development board. Okay, so using this board I'm going to add a computational intelligence to this device. Okay, now this is not an IoT, just, okay, so I'm just adding a computational intelligence to this device. Okay, so now, okay, if I want to make IoT, okay, so if I want to make IoT, what needs to be added to this? Okay, definitely I need to add a one more thing. What is that thing? I need to add a connectivity. So now this becomes a thing in an IoT. Now what is a thing? It's a thing, right? It's a refrigerator. It has some basic purpose. Okay, so it has some basic purpose. Okay, so to this refrigerator I add a computational intelligence using this embedded device. Okay, embedded board. Okay, so definitely in this embedded board, what is the intelligence in this board, right? Okay, so in this board there is some software running. Okay, and there will be some sensors in it, there will be some actuators in it. Okay, so using sensors and actuators, okay, I can do some computationally, okay, some intelligent task in this refrigerator using this board. Okay, so for example I want to maintain some, okay, I want to for example, if door is open for, okay, door is open for some 30. Okay, for example, using this computational intelligence, what I can achieve, for example, you may think like that. Okay, for example, door is open for some 30 seconds, so you'll get a beep sound, right? So that I can do, right? So or if you are okay, some temperature control inside it. Okay, I can maintain certain temperature using a software, right? So this is, okay, you think like that. So first thing is, so just wait. So sorry guys, just a confusion. Okay, so see here. So what I'm trying to do to this refrigerator, I'm adding some computational intelligence. Okay, using this board. Using this, for one of the example thing, what I can do is I can develop a system inside the refrigerator such that when I open the door for more than 30 seconds, I can produce a beep sound. Okay, see for that definitely, okay, in order to sense that whatever the door is open, in order to do that automatically, I can use some sensors and actuators. Okay, so in this, so like that. So but that is not an IoT. Okay, just adding a computational intelligence. Now what I can do, if I add computational intelligence plus connectivity, right? So I can connect to a common platform called internet. Okay, so that I can connect this internet. Okay, I can connect this refrigerator, which I am claiming as a thing. Okay, so this thing I can connect to an internet. Okay, so if I add the connectivity feature also to this, then it will become an IoT, right? Internet of a thing. Okay, this is one thing. So what is internet of thing? So such a huge number of things are connected, right? I can connect refrigerators, I can connect, okay, smartphones, I can connect your pen, okay, your shoes, whatever it may be, a classroom, your chair, okay, your smart lights in your home, right? Or your car can be connected to a net, right? So such a thing, right? So how to get a thing, okay, how to get a thing in an IoT? So for a thing, existing thing, I can add some computational intelligence for some purpose, right? Definitely there will be some purpose is there. I want to do certain thing, okay, I want to make this smart, right? For that I'm adding computational intelligence. So if I'm able to connect such a device, add a connectivity also. Adding connectivity is nothing but connecting this to internet, right? So if there is a thing, there is a computational intelligence, there is a connectivity. So this is the actual thing in the internet of things, right? So this is the basic understanding, right? So there is an environment, okay, which is a thing. So in this environment, I need to make some control, right? Okay, I need to make some control. For that, I need to have some sensors and actuators. Okay, so that sensors and actuators are interfaced to this, are put in this board. Okay, sensors and actuators that we'll see today how to keep that. Okay, sensors and actuators. Then we have some intelligence in it, right? We have a processor or microcontroller in this board. So which has a software. So that software is a intelligent, right? That is an intelligence actually. That is an intelligence incorporated in it. That software, okay, that software is able to control this environment. For example, whatever it may be. Okay, so that we'll see, and also this it able to have a connectivity, internet connectivity, right? So this is the basic idea of what is a thing inside a in a internet of things. Okay, so with this idea, okay, now you see this. Okay, what is the purpose of traditional refrigerator? Just to keep items cold. Okay, that's it, right? No other purpose, right or not? See, whatever we keep inside, it will keep in, we can set a temperature inside it. Okay, so according to the temperature, it will maintain the temperature inside a fridge, right? So that is the basic purpose of this traditional refrigerator. Okay, so if I go to intelligent refrigerator means just I'm adding this, okay, I'm just adding this refrigerator plus some computation, right? Some intelligent device. So if I, for this I can get what I can get. Okay, so for example, I can get this when the door is azar in the sense whenever the door is open, you can get an alarm, right? So alarm rings, right? Alarm, okay, that is a intelligent refrigerator, right? So when the water filter needs replacing, for example, your water filter, okay, okay, needs replacing when you are low on butter. Okay, so when you buy foods with high fat content, right or not? So for example, you have some food inside the fridge which is of high fat content, right? You can detect that with the help of some sensors, that fat content, and you can report that, right? So what recipes match its contents, right? So you inside a fridge, for example, you want to know, right, what you can do with the contents of your fridge. For example, inside a fridge, you have a tomato, you have some vegetables are there. So based on that, it can tell you some recipe. It can tell you like you can make a sambar today. You can make some vegetable curry today. Like that, you can get a recipe. So all this automation can be done with the help of that intelligence, right? Whatever the intelligent hardware we are using, right? So we are using some microcontroller board, okay, development board. In that board, we have a software. So using that software, you can make these automations. Not only that software, also you should use the sensors and actuators. So sensors and actuators and processor, these are all the hardware and the software running inside that processor. Okay, So this forms this hardware, and using this hardware and software combinations, you can take some intelligence, you can add some intelligence to this refrigerator. Okay, so this is not an IoT. So this is just a using sensors, okay, actuators, and right. For example, okay, based on that sensor and based on that sensor data, you can control these things, right? For example, if your door is open, you can sense that activity. Okay, you can have some threshold time. Maybe if his door is open for greater than 30 seconds, you can turn on the buzzer, right? This is not an IoT project. You can directly do it, right? You no need to connect to the internet, right? So you can directly do that. For example, you want to suggest some recipes, right? So based on some sensor data, what you can do, you can know that, right? Okay, today in the fridge there is a butter is there, so there is a Maggie is there. So based on that, you can tell, right? I can use an omelette. Okay, for example, I can make an omelette based on the eggs are there, like that, right? So that is not an IoT. Now what you can achieve with IoT? So this is an IoT refrigerator. So using the IoT refrigerator, you can achieve this kind of things. Okay. So for example, order food items when stock is low. For example, what your fridges do? For example, you have only eggs. Okay. Eggs are only one egg is there. Now fridge, what it will do? It can sense that activity. Only one egg is there. Now it can go to the automatically. It can order in the website. Okay. So eggs are over. So like that. So that is an IoT, right? For example, searches for the lowest food prices, right? So this automatically it can search for example, something is over. So it can go to the internet. Okay. So in that internet, it can search for whether Big Basket is offering the less cost, or some other Big Bazaar is offering the less cost. Okay. So which is offering less cost, so that it can predict, that it can find, right? So such advanced applications you can achieve. Okay. So okay, you can achieve, right? So what right? Also, so what is your, so you are keeping some things, right? So based on whatever the food you like, so it can recommend you some things, some recipes, right or not? So it can search. So all these things can be these are the advanced applications possible with the IoT refrigerator. Okay. So see here, just three things: traditional refrigerator, intelligent refrigerator, IoT refrigerator, right? So traditional refrigerator, just it has a whatever the mechanical, electromechanical things are there to develop a refrigerator, that will be there. But intelligent refrigerator has an extra capability of sensors, actuators, and that computation embedded hardware. Okay, and the which is called a microcontroller or microprocessor. Okay. So your IoT refrigerator, what it has a computational capability. Also, it has a network connectivity. It is connected to the network. Okay. So that is what the IoT should understand. So definitely, so first question I also observed in our college, right? Whenever you do any IoT project, okay, you went to, okay, whenever you do any IoT project and you go to the Viva, definitely they will ask a question whether IoT is required for your application or not. You cannot claim that, okay, you did something and it is an IoT is required. So definitely, if IoT is required, then only you should able to incorporate IoT, right? So without IoT also we can do many things, right or not? So that thing you should able to justify in your project. This is the first thing, right? So you did some project, Babu. Okay, what I'm telling is you did some project. Okay, so you are claiming that this is an IoT project. Okay, so you should give the valid reason. So why you are connecting that, whatever the thing you are doing, why you are connecting to the net? By connecting to the net, what advantage you are getting? That you should able to identify in your project. Okay, so this thing you remember while doing any IoT projects, right or not? So okay, so so like this I can convert this chair. Okay, if I want to convert this chair to a thing in IoT, what I need to do? For example, I need to identify whether some person is sitting or not in this chair. Okay, so that I can identify using a pressure sensor. For example, I can identify using a pressure sensor. Okay, so using a pressure sensor and heat sensor, I can do that whether my chair is occupied or not, right? So how to make this IoT? Okay, how to make this a thing in an IoT? I need to add a computational intelligence as well as the connectivity, like whatever we did for refrigerator, the same thing we need to do for okay, to do for this, okay, chair, like that. Okay, you can take anything, you can take a shoes. Okay, you want to track your activity. Okay, so you can put some embedded device inside your shoes, right? So that have some sensors. Okay, so based on that you can track your activity, right? So like that, Okay, so this is a basic way of converting a thing to an IoT, Internet of Thing. Okay, whatever the thing. Okay, so this is what, right? Just a 5 minutes of this. You just see this. So definitely this graph tell that, okay, so it is a technology adoption. Okay, so it's a x-axis represents the years, okay, year, and y-axis represents the population penetration, right? Population penetration is how many people are adopting this technology, right or not? So definitely AM radio it took some time to adopt, to get into 80%. Okay, like TV took some, okay, some less time. Okay, internet, mobile internet, like you can see this mobile internet. Okay, it rises sharply, like okay, it started in 2004. Okay, like within less than 10 years, okay, it able to adopt by the people, right? So this, because of this mobile internet only, people are able to think of this IoT applications. Okay, so that's what this because of the rise in internet and mobile internet, so this IoT is rising. Okay, so another thing is this is a global per capita GDP. Okay, the point is why everyone is talking about IoT, right? So that why everyone is talking about IoT is, see here, whenever they invented the printing press, so GDP per, okay, per capita, what is this GDP? So it is the average income, okay, in a country, what is the average income earned by an individual, right? So that does not rise. Even when a steam engine was invented, does 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 not rise. But whenever the worldwide www, world wide web, internet was invented, okay, so it rised, right? So definitely, so it IoT will improve the per capita. So that's the point here. So in the business in the context of business also, okay, so in the context of this GDP also, your okay, IoT okay, improves. Okay, whatever it may be, you see this is a industrial revolution. So first industrial revolution is, okay, like people used to use this steam engine and coal. Okay, to it started in Great Britain, post industrial revolution, right? They used to use this mechanical, okay, mechanical production. So in industry they are manufacturing, right? So they are using these mechanical productions. Okay, so this is the first industrial revolution. Second industrial revolution is they used to, okay, started in Europe and America. They used electricity, petrol and steel, all these things. So they used to they used mass production, right? So mass production came into picture. Okay, so but this requires labor and electrical energy. Okay, this is the second industrial revolution. So third industrial revolution is about electronics and IT. So they got automation, right? Production automation, right? So this is the third industrial. Now the fourth industrial revolution is about okay, so this different, using these different technologies, they are adopting this in the industry. So what are these different technologies is IoT, artificial intelligence and big data, right or not? So using IoT, artificial intelligence and big data, they are they're manufacturing their products in the industries, right? So this is about the IoT, importance of IoT. Okay, so definitely what is an IoT? So IoT stands for Internet of Things. Okay, so objects that are not currently joined to a computer network, namely the internet. So you already know, right? Now what internet is means, you think that only your computers, right? Computers, laptops, these are connected to internet. But the goal of IoT is to connect the unconnected, like connect the unconnected. Like you can connect your chairs, you can connect your bulbs. Okay, you can connect your garage door. Okay, you can connect your doors, you can connect whatever it may be, right? So all these unconnected things, if you connect, okay, this is the main goal of IoT. Okay, so IoT is a technology transition. Definitely IoT promise efficiency, accuracy, automation, see whatever it may be. Okay, these are all covered by sir. Okay, so already this also saw told. Okay, he's a Kevin Austin, right? So this is the first IoT device. Okay, so they incorporated this thing, like this kind of intelligence in a vending machine, Coca-Cola vending machine. Okay, so definitely what it will report is it will report about many things, like it can report, okay, this Coke is over. Okay, it needs to be refilled. Okay, so that thing it will automatically, it can predict with the help of sensors. Okay, and one more thing is whether whatever the Coca-Cola is put into this vending machine, whether it is cold or not. Okay, whether it is ready to serve or not. So that information also it will provide, right? So this is the first device they used this kind of intelligence in for a thing, okay, for a Coca-Cola vending machine, okay. So you can see not only not only a thing means not only a non-living, you can also have this cattle as a things. For example, in case of on country, okay, they have this startup company, okay. See what is this thing is they connect all these cows, okay, all these cows they connect to internet. See what for what, right? For what means whenever, okay, a cow is sick, okay, based on that sensor, all the sensors are deployed in the cow. Whenever a cow is sick or cow is pregnant, it sends message to a farmer. Automatically farmer get noticed whether that cow is pregnant or cow is sick. Okay, this is some Dutch startup company. Like that many companies are coming, right? You know, right? Based on drones, right? Smart farming based on wireless sensor networks, right? So whatever it may be, okay. So for example, you can deploy, you can make a intelligent, for example, for our VNR college, you may deploy very many sensors. For example, you can deploy some pollution. You want to find the pollution rate in our college, okay. You want to also notify whether which zone is having more more pollutants, right? Like that, if you want to do any project, you can deploy all the like cattle. You can connect all the sensors, pollution sensors. You can deploy in our vicinity, VNR Vignan Jyoti College, okay. Then you can start collecting the data, right, from it. Then based on the data, you can find out which area is affected more, okay, which area is affected by the pollution, and you can propose some solution, right? That is one IoT, right? So like that you can come up with many projects, right or not? So right, so definitely this is some technology. So this is a initial car, okay, with some electromechanical control. Like now 21st century car, okay, because of these technologies, okay, we have a computer based control, okay. So we have anti-lock braking, okay, all this computer based control. So here the electromechanical control is replaced by this embedded based control, okay. Like logistics, okay, people are using barcode. Now we have a RFID tags, okay. So these are the different applications. Anyway, SAR has covered, okay. Smart home, smart infrastructure, so all these things, okay. Okay, Babu. So now we'll move to this with this introduction, we'll move to the practical session, okay. So what I want to show here is, definitely I told that you want to make a thing, you want to add a computational intelligence, okay. So you can add a computational intelligence via such embedded device, okay. On the screen you see one embedded development board called Arduino Uno, okay. So this is the basic development board, Arduino Uno, okay. So using this board, okay, for example, I can add some intelligence, like I can have some temperature sensor, okay. I can connect some sensor to it. So based on the requirement, right? For example, you want to monitor your gas leakage in your home, okay. So how to do that? So definitely you need to have such a device first, development board. It may be Arduino, or it may be whatever it may be. It may be ESP, okay, Node MCU, whatever it may be, or BeagleBone or Raspberry Pi, whatever it may be. You start with the development board, okay. For such a development board, what you do if you want to detect a gas in your home? So what gas? So particular chemical, right? So that chemical based sensor you have to use, okay. You have to interface that sensor to it, okay. Then you can have some control, maybe turning off the valve of the gas. You can have some control action also, okay. Like you need to shut down that okay, a valve, gas valve, okay. So that thing can be done by actuator. See whatever it may be. So your sensors and actuators, these forms the basic, okay, basic thing. Like you want to turn on the, okay, you want to turn on the AC. How to turn on the AC? Automatically you are going to your home, right? You are almost 5 kilometers away from your home. You are driving in a car. So from a car you can have a directly, you can click a button directly before you enter your home. Your AC is on and your room is very cool, right? So for that, what you are doing there, you are just operating the actuator. You are by using you are connecting some actuator and you are trying to on that okay, on your AC, okay. So like that, right? Many applications you can do based on the requirement, whatever it may be. You need to know about this basic thing. So this is a development board, you can see here. So definitely these development boards okay, is controlled by a microcontroller, okay. So you can see this arrow mark, whichever I'm showing. This is a microcontroller. What is a microcontroller? Okay, microcontroller is nothing but it's a CPU. Okay, Babu. So it's a CPU. Okay. So what it will do, CPU will do. So in CPU, what it will do, it will execute a software. Okay, whatever the C code we are writing. Okay, whatever the C code we are writing, code. Okay, whatever it may be, C or Python or whatever it may be, whatever the code we are writing, see that code is executed by this processor. Okay, or microcontroller. Okay, so simple example, what code it can do. For example, to this analog input, I can connect one, okay, temperature sensor. For example, I can connect one temperature sensor. Now, okay, I can connect one temperature sensor and I can connect one motor. Okay, motor to this digital IO pins. I can connect one motor, right? So now I need to write a software in this. What software I need to write? I need to read the temperature value. Okay, if the temperature value is greater than 30 degrees centigrade, I need to turn on the motor, right? So that software I can write. So what I can write? I can read that temperature sensor value. Okay, so inside that right, if else all these conditions. Okay, anyway, software means we can have all these programming constructs. Using that constructs, what I can do, I can read the temperature value. Okay, I can compare that with some threshold value, and I can turn on the I can turn on the motor, right? So for that, what I need to do, I need to design, first of all, I need to design a hardware. I need to interface a temperature sensor. Okay, then I need to interface a motor. Okay, so then I can write a software for that. So this is the basic, whatever the thing. Okay, whatever the thing, for example, for that thing I'm adding the computational intelligence with the help of such a development board. Okay, for example, gas leakage, you can fix this inside the gas, near the gas, right? Wherever the gas leakage is possible to occur, you can have that gas leakage. Okay, so for example, based on the, if gas is leakage, okay, you can turn on that. Of course, you may not turn off the valve of the gas, that is not possible, but you can turn on that your one fan will be the exhaust fan will be there, right? So that exhaust fan you can turn on. So for example, if you detect the gas leakage, you can turn on the exhaust fan, right? That you can do. Okay, for what is exhaust fan? Exhaust fan is controlled by a motor, right or not? You can turn on that motor, that exhaust fan will turn on. It's like that, right? So definitely whatever the gas leakage is, that will be blowed out your home. Okay, so like that. So like that applications you want to do. Okay, so this is the basic development board, Babu. So this the development board, all these things you don't know, nothing you know, right? So but we'll do some simulations, right? So this will be continued in the coming sessions. Definitely tomorrow a microcontroller faculty will teach about what is microprocessor, what is a microcontroller, what is this interfaces, all these things they will discuss. Okay, so that flow will go from the next session, but this session you just see this. So you just have this Arduino Uno board. Okay, most of you know this. Okay, if you don't know, just listen this. Okay, this is Arduino Uno. This has some microcontroller in it. Okay, this is the microcontroller. So also it has some digital IO pins. Okay, so digital IO pins are there. Also it has analog inputs. Okay, analog inputs and digital IO. Digital IO means digital input and output both. Analog input means only inputs. Okay, so this board is able to process only analog input, but it cannot generate an analog output. Okay, it can generate a digital output, but it cannot generate an analog output. Only analog input I can give. You know what is the difference between analog and digital, right? So okay, so we can have this power. Okay, 5 volts power, 3.3 volts ground. So this power, okay, I can give power to the sensors with the help of this. Okay, these pins. Like that I have this I2C. Okay, few sensors require this I2C interface. Just now Sir told about some interfaces. Okay, some protocols. Okay, so I2C is one interface I can use to interface some sensors. Okay, so this is a reset button. So this is a USB. So this USB I need to connect to the computer. Okay, in order to do the programming. Okay, definitely most of you know that for the Arduino there is a software called Arduino IDE. So in the Arduino IDE I'll write a code. Okay, so that code I'll put in this processor, so that the code will run in the processor and it do whatever I intend to do. Okay, so this is the power button. So here I need to provide the power. Okay, see whatever it may be, it's a 9 volts DC power. Okay, so just to give you a feel, just we start directly go to this simulation part. Okay, so if you type this Tinkercad, there is one software called website called Tinkercad. Okay, so just go to this Tinkercad and you can create a you can create an account in this. Okay, if you have any Gmail account, whatever it may be, you can create a you can create an account in this. Okay, so definitely after creating an account you'll get like this dashboard. Okay, so you can create a new design. Okay, just click on it. Here you can click on it. Okay, so here you will get. Okay, so just click on this. So not 3D design, we are going to design. So go to the circuits first. Okay, so circuits, go to the circuits first. Okay, so 3D design circuits are there. So go to the circuits, then create a new circuit. Okay, create a new circuit. Okay, so after you create a new circuit, okay, so we try to find for Arduino. Okay, so Arduino, just click on it, just drag it. Okay, so okay, so this is Arduino, this is what. Okay, this is using such a board. Okay, this is one of the board, right? Like that many boards are there. Okay, this is a basic board. Okay, so using such board I can incorporate the intelligence. Okay, I can incorporate the computational intelligence to my thing. Okay, that thing may be refrigerator, that may be a gas cylinder, that may be a light, that may be fan. Okay, whatever it may be. Okay, so this is the thing. Okay, so just first what I try to do, we try to interface some simple thing. Okay, so first we start with 2-3 interfaces I will tell. So first thing is we'll start with simple thing called LED. Okay, so definitely if you want to interface LED, you can search for LED. Okay, so light emitting diode. Okay, so this is just a starting, right? Anyone who tells this, they start with LED. Okay, so just drag this LED. Okay, so LED, where you connect LED. Okay, so LED definitely you need to connect to this digital IO pins. Okay, so just I told, right? So this is a digital IO pins out there. So LED is connected to. Okay, so first of all, what is LED? LED is a output, right? So I want to on the LED from writing the software. Okay, so by writing the software in this microcontroller, I need to turn on this LED, right or not? See, basically what is LED? It's a PN junction, right? So PN junction, if I give a forward bias, okay, if I give a forward bias to this LED, okay, so with some voltage drop, maybe 1.2 volts, okay, voltage drop, okay, forward voltage drop, this LED will turn on. Okay, now this that thing I can do directly, right? If I connect a 5 volt supply, I can that will on, right? Suppose if I connect a anode, okay, 5 volts, and cathode ground, it will turn on automatic. It will turn on, right? Keep on, it will turn on, right? But that is not the point. I need to control that. Okay, so I need to control that. I need to control, right? So for that, what I do, I connect this anode, okay, which is a positive. I connect to one of the pins, right? So you can see here 0 to 13. So these are the digital IO pins. Okay, so digital IO pins I need to connect to, okay, one of the pin. I can connect to any pin. For example, I can connect to this pin number 13. Just drag and okay, so that connection is over. Okay, so to this pin, this is what anode, right? Anode means this positive. Okay, so this cathode I need to connect to the ground. Okay, so cathode I just connect to the ground. Okay, okay, just a cathode I connect to the ground. Okay, Babu. So now what, directly it will run, it will not run, right? I need to code in this. Okay. What is happening? I need to start coding in this. Okay. For that, you just go to the code here. Okay. So in this, you just select this text. Okay. Just select the text. Keep continue. Okay. This is the code. Okay. So this is the basic code. Okay. Already I got this code, but I need to do this. But for a LED, definitely this website provider, you will automatically provide this code. So you can see this is the basic Arduino code. Okay, so this is the basic Arduino code. So this code, by writing such a software, I'm controlling this LED. Okay, so I'm controlling this LED. Okay, for that, what I'm trying to do here. So see here, this has a two functions. Okay, one is a setup function and another is a loop function. You can think. Okay, just setup is a initialization. Okay, whatever the initialization code I need to write, so that all the initialization code I can write in the setup. Okay, and loop is nothing but it will, whenever I turn on the power, it will continuously run this code. Okay, it will continuously run this code. Okay, so that is the basic. Okay, basic code. Okay, see what the initialization I'm doing here. So definitely I told that, okay, these pins are, okay, whatever the pins 0 to 13, these are the IO pins. Okay, IO means input and output. Okay, but I need to configure whether I want input functionality or output functionality. That thing I need to configure. So that configuration I can do by writing pin mode function. Okay, so pin mode. So 13 pin, I want that pin as output pin. Why? In the 13 pin I have connected the LED. Okay, I have connected the LED. So output pin. Okay, now, okay, now in the loop, what functionality I want to write? For example, I want to toggle this LED. Okay, toggle means I want to turn on, after some time turn off, turn on, turn off, turn on, turn, like toggle on off, that thing I want to do. See, for that, what I need to write? Okay, first I need to high. High means, so 13 pin, I'm writing 13 pin high. High means 5 volts. Okay, so then 13 pin I'm writing low, 0, right? So here that LED will on, so it will remain on for some delay. This is a function, right? All these functions are available in the Arduino. Okay, again I am writing low, turn off the LED, again wait for some time. Okay, again turn on. So this loop will keep on running. This is the basic software which is controlling that LED, right? So if I start simulation, just after coding, just start simulation. Okay, so it keep on, you can see the blinking LED is blinking. Okay, so but you are getting some warning. Okay, so you are getting the warning. You see what is the warning here? So current through. Okay, so just I'll grab that. Okay, so just see that warning. How to avoid that warning? Can anyone tell? So first see what is that warning. Okay, you can see the warning here. Okay, warning is current through the LED is 35.6 milliampere, while the recommended maximum is 20 milliampere, right? So because of this, the lifetime of the LED may be reduced, right? So how to do this? So you are getting the more current, because of that lifetime may be reduced. So but practically what you do, how you connect LED? Okay, practically. So just I stop simulation. So practically how you connect LED? Okay, so rather than directly connecting a LED, how you do? You connect a resistor, right? So if you connect a resistor, okay, so what resistance, how much resistance value? So maximum what he has given. So he has given, okay, so for example, how to design a resistor value, how much resistance I need to use. Okay, so you know that, okay, V is equals to IR. Okay, I know maximum current I is equals to 20 milliampere. Okay, so okay, I know V is equals to 5 volts. Okay, then what is R? Okay, so what is R? You'll get if you find using this equation, you get R as 250 ohms. Okay, so I can use 250 or more than 250. Okay, whatever it may be. For example, see here, I just configure this as, okay, ohms. Okay, 250 ohms. Okay, okay, now what I do? So I connect this. Okay, now we via this resistor. Okay, so okay, so this thing I connect here. Okay, this thing I connect to 13. Okay, so this thing I connect to ground. Okay, now you start code, same code, right? Same code. Okay, but okay, so now you start simulation. Okay, so definitely that warning will go, right? Now we are what is this resistor? This is called a current limiting resistor. Okay, so this is called a current limiting resistor. Okay, Babu. So LED is one output device, right? So with this demonstration, what you understood? Okay, see, just I introduced IoT as something, okay, which has a which is a thing, right? Which is a normal thing like a fan or table or a cooker, whatever it may be, or your fridge or AC or car, whatever it may be, such a thing, right? So you add some intelligence to it. Okay, how to add intelligence to it? Okay, so with the help of such a device, with the help of such microcontroller board. So to this microcontroller board, of course, so you not not this LED, you connect the sensors and actuators. Okay, after connecting that, so like here I am connecting LED, right? Like that you connect sensors, actuators, like motors. Actuator means motor. For example, motor you can connect some temperature sensors, ultrasonic sensors, many sensors, right? Based on your application. Okay, you can connect sensors and actuators. Okay, then after connecting it, that is the hardware part. That is the hardware part, first part. Okay, then after finishing the hardware part, you need to write a software. Okay, so this software you need to develop in a desktop in your computer, and you need to put the dump this software into this microcontroller. Now, okay, now whenever you turn on this, okay, whatever the software you have written, accordingly that will work. Okay, so accordingly that will work. Okay, so this is one of the simple, okay, simple thing. Okay, so next, okay, so next we'll see one more. Okay, okay, now, okay, I can also use this serial monitor. Okay, so here I can also use this serial monitor. See, what is this serial monitor? I can do some, okay, I can do some printing here. Okay, so what is the serial monitor is? So you just see this. So just this board I'm connecting to the computer, right? Okay, this board I'm connecting to the computer. So whatever the data, some data, I can transfer that data to the computer. Okay, so how to do that? So for that I need to write some code, extra code for that. Okay, so for example, see here, I need to initialize that serial communication. For example, serial, okay, begin. See, please don't, if you don't understand, okay, just see this. Okay, all the next whatever the next sessions, okay, they will explore. Okay, in the next session, what they tell what is this microcontroller, what is the difference between microprocessor and microcontroller, what is Arduino, what is Raspberry Pi. Okay, all this, what is architecture, all these things they will cover in the next sessions. Okay, this is just a practical. Why means, see here, why I am telling this is, for example, you got some idea, Babu, you know that idea, you want to, rather than directly buying the hardware and checking that idea works or not, so you go for this Tinkercad, right? You connect Arduino, you know, or whatever the Arduino board you want to use, you connect the sensors, you connect the actuators, and you simulate it first of all. So if that idea works in simulation, then go for the hardware design. Okay, so that like that you can plan for simple projects. Initially you can plan for simple projects. Okay, like then you can go for the complex projects. Okay, for simple projects people prefer Arduino. Okay, so to learn, right? Basically to learn. Okay, so just I need to give this serial begin. Okay, so for doing serial communication between the CPU and your board, you need to set this baud rate. Okay, this is the 9600. This is a baud rate. So this is one of the baud rate is a communication parameter. Okay, so just I need to, okay, just I'll print, right? If it is high, just I print a message. Okay, okay, serial dot for example print length. Okay, LED on. Okay, so this message I'm printing. Okay, then I give delay, then I write low, then okay, serial dot, okay, uh, so this is just a serial communication. Okay, for example, if I start simulation, okay, you can see the serial monitor. If I start simulation, okay, so definitely whenever the LED is on, the message also printing. You can observe that in the serial monitor. Okay, whenever the LED is off, so like that, right? So what is the advantage of such thing? Okay, see, you are not, you don't know, right? You don't know if you write such a software, if you write such a software, how this processor is executing that software. No need to bother about. Okay, no need to bother about. See how this hardware works, how this LED works, whether okay, no need to bother. You just need to know, right? What you need to know. You just need to know, okay, this maximum capacity, maximum current carrying capacity of this LED is 20 milliampere. If I put more than 20 milliampere, okay, this LED will burn off, right? That information. How to know that information? There will be a data sheet. Okay, that information you should know. Based on that, you design this resistor. Okay, resistor, and you connect this resistor. So there is some this circuit you need to design by your own, right? Then you should know how to connect this LED to a board, right? So how to connect, that information is, okay, I need to connect to output. Okay, since LED is output device, okay, it's output device. Okay, I need to connect to the output pin. Okay, okay, you know, right? So that thing, okay, so just you need to know, right? You're configuring output. Okay, so you're to use serial communication, just use this like that, right? Without knowing the much detail, right? How this code executes. So you can abstract all those details and directly you can write this function, right? That is the advantage of Arduino, right or not? So normally if you want to write the same code with some other, okay, some other microcontroller microprocessor, you need to use the assembly instructions. Like you need to use add, subtract, like that instructions. Okay, that concepts will be told by tomorrow that faculties. Okay, so that's the very simple, right? You can start, you can buy a board. Okay, you can connect to whatever you want. Okay, you start writing code and you can control that. So this is the basic stuff of IoT. Okay, so now we'll go for one more simulation thing. Okay, now so this is something output device, right? Now we try to connect some analog input like potentiometer, right? You know what is potentiometer? Okay, so we try to connect a potentiometer and we try to see, okay, what's how to write a code for that. Okay, that is one more thing. Okay, so this is just to give a one input, one output device and one input device. Okay, so just I remove this. So this is a potentiometer, Babu. Okay, so see, I want to connect a potentiometer to this. Okay, I want to connect a potentiometer. Okay, so potentiometer has three things. Okay, terminal 1, okay, terminal 2, okay, and wiper. Okay, so this terminal 1, okay, you know what is potentiometer, right? It's a voltage, okay, voltage divider circuit. Two resistors it has. Okay, you take the output in the middle, right? So that is this output. So this I need to connect to one analog pin. Okay, so for example A0, I can connect to analog input. Okay, so this terminal 1 I need to connect to supply. Okay, for example 5-volt supply. Okay, so this terminal 2 I can connect to ground. Okay, I can connect to ground, right? So this is a simple connection, that's it. Okay, now if I start writing coding, okay, if I start writing coding for this, okay, if I start writing coding for this, okay, just what I do, whatever I read the analog input, okay, so I can vary this potentiometer. Okay, so I can vary this potentiometer. Okay, so okay, this is a 250 kilo ohms, okay, maximum. So if I can vary this knob, definitely that resistance varies. So whatever the data, that input data, that I can show in the serial monitor. Okay, see, for that I start coding. Okay, so anyway, this is a, that's what I told. This is the default code available in this. Okay, just I remove this code. Now the purpose is not LED, right? My hardware is something different. Now I use a potentiometer. Then I should know how to control this, how to read the values of potentiometer. Okay, definitely I try to use a, okay, whatever the data I read. Okay, I use one integer variable to, okay, read that data. definitely this coding, whatever the coding from the scratch will be explained at last, right? You know, right, in the sessions we have a Ramesh Reddy sir, Balakrishna sir sessions are there. At that time they come up with physical, right, physical board, they install the Arduino and they try to explain that. So before that, this is just to give a feel. Okay, simulations. Okay, just I use begin. Okay, just I configure the serial communication. Okay, baud rate 9600. Okay, then I write a loop. So in the loop, what I write, I write that pin. Okay, pin value. Okay, so pin value, and I need to display in the serial monitor. Here serial monitor. For that I am writing the code. Okay, so the code is whatever the read. Okay, this is stored in that variable. Okay, here the function is analog read. Okay, so these functions, these are all available, readily available in the Arduino. Okay, so okay, analog read, that's it. A0 is the pin. Okay, I'm connecting in the A0 pin. Okay, so the data, whichever the potentiometer data. Okay, so that thing. So another thing is now I need to display that whatever the value I have read. Okay, I need to display in the serial monitor. Okay, for that serial dot, okay, read. Okay, that variable I display, right? It's very easy, right? Whatever the C language, then I give some delay. Okay, code, right? So now you can see this. If I start simulation. Okay, so you can see this 1023. So 1023 is a maximum value. Okay, now I can change this knob. See here, if I change this knob to I get a 962. Okay, so if I change this knob, okay, I get a 859. Okay, so like that I can change this knob. Okay, I get different values. Okay, so this is the half value. Okay, so okay, so this is a potentiometer, simple potentiometer. Okay, so okay, so I can get a minimum value 0. So 0 to 1023. Okay, so it is showing 0 to 1023. Okay, so values. So this is about the simple potentiometer. Okay, Babu, I think you got some feel, right? So these are the two simple things. One is output thing I shown, one is the input thing I shown. Of course, digital output and analog input I shown. Now we'll see, using the similar concept, we try to interface a temperature sensor. Okay, so I will show the demonstration of temperature sensor. Okay, so that will give some feel to you. Okay, for example, see Nana, I want to, okay, so don't bother about what is this coding. Okay, all these things. Okay, just you know that there is one website today, at least what is the take home point. Take home point is, okay, you know that what is IoT. Okay, so IoT, I have something is there. So for that thing I need to make a thing in IoT. For that, what I need to do, I need to add some computational intelligence to it. Also I need to add the connectivity. Of course, here I'm not showing a connectivity, right? I'm not showing any connectivity, like I'm not adding any internet to it. So internet, that Bluetooth internet simulations, we cannot do using this. Just we can do these simulations. Whatever we can connect the embedded, whatever the sensors and that, and you can see that simulations in this. Okay, so that you will see in the real time, right? After, by how to connect this to the internet. Okay, so how to connect this board to the internet. So definitely we need some Wi-Fi. Okay, we need some Wi-Fi or some other things we require in order to connect this to internet. Okay, so that thing we'll see practically in the coming sessions. Okay, so now we'll next thing is we try to interface some sensor. Okay, so that we'll have some feel. Okay, so let me remove this. Okay, so we'll try to interface some sensor. Okay, so temperature sensor. Okay, so for example, okay, I need to read a temperature of the environment. For example, this application, now many startups are also there. For example, maintaining the server room. So in many situations you need to maintain a temperature, right, at particular constant level, right? For example, in a server rooms, okay, or in some industries. Okay, in such a scenario, this they deploy such a device. Okay, so they deploy the temperature sensors. Okay, so based on the temperature sensor data, they take decision, right? So for example, I can interface a basic temperature sensor. Okay, for example, there are many sensors out there. Okay, so TMP36. Okay, this is one temperature sensor. This is analog sensor. Okay, so it will read it will get the analog output. Okay, so Okay, TMP 36. Okay, Babu. So just go to the internet and see TMP 36. Okay, so temperature sensor. Okay, then you can find that sensor related. Okay, okay. So for every whatever the instrument you use here, like Arduino or a sensor or resistor, whatever the component you use, that component will have a corresponding data sheet. Okay, so in the data sheet all the related specifications will be mentioned. Okay, so in the data sheet all the related okay, for example you see this analog device TMP36 from analog devices. Okay, you can open a data sheet and you can see all the related information, okay, regarding that sensor. Okay, what that sensor is, okay, what is the pin configuration. Okay, so the sensor, so this is just an integrated circuit, so this is the pin configuration of that sensor. Okay, so it will, so all this information you can find out using this okay, using the data sheet. That's the information, right? So using the data sheet you can find all that information, right? So just I'm using that okay, I already know how to interface this. Okay, so this has a 3 terminals, power, okay, V out and ground, definitely like potentiometer, right? So this first of all, okay, this power term I connect to, okay, 5 volts. Okay, this ground I just connect to ground. Okay, this data, whatever the data V out I take, okay, and I connect to analog input. Okay, so this is the analog input. Okay, Babu. So this is a simple interfacing of this temperature sensor analog, so which is a TMP36. Okay, so like that many for example you can get a DST11, right? So that is a digital sensor, so that gives directly the digital output, temperature output. So but this provides an analog output. Okay, analog output. Okay, so how to write a code for this? Okay, just see this, just we need to write a code for this. Okay, then I need to read, okay, what is the temperature in that environment. I can also simulate that. Okay, what is the temperature, I can adjust the temperature. It's a simulation, right? So whatever the temperature is there, I can read in the serial monitor. Okay, so I can start coding for that. Okay, so just I require one more variable called double. Okay, so just see this code. Okay, anyway. Okay, so I need to use this okay, same thing, same code, right? I'm connecting a naught. Okay, I read this. Okay, then okay, first of all I delete this temp. Okay, to show you something. Okay, then I read this directly. Okay, and if I print this, what I'll get, try to see here, the start simulation. Okay, so see here, you're getting some, okay, you're getting 153. Okay, you're getting 153. So generally this thing I can control, right? This is the 25 degrees centigrade. So I am not getting directly 25 degrees centigrade, right? Instead of what I'm getting a 153, right or not? So if I change this okay, if I change this to 44 degrees centigrade, for 44 degrees centigrade you are getting, okay, 194. Okay, for example if I reduce, for example I can reduce up to minus 40 degrees centigrade. For minus 40 I get 20 value, but that is not right? I need to do something to get the exact minus 40. I need to show here, right? Okay, so if I get maximum 125, for 125 you get 358, right or not? So definitely this is not enough. I need to do some other thing such that I need to display the exact value. Okay, so what to do that, how to do that? Okay, that is the point I'm trying to explain. So what I'm trying to explain here is, definitely after reading the sensor value, okay, you need to show that exact value. For example, here I have a system LCD, I need to display this temperature. So not only just reading is enough, you need to do certain computations here, okay, such that you get the exact value. Okay, so for example for this sensor, what computation I need to do is, you see here. Okay, just to declare one more variable. These are just ideas, right? So I need to declare one more variable, for example floating point double. Okay, okay, what I do is, okay, I read this value. Okay, after reading this, okay, then I use a temp. Okay, temp is equals to cast. Okay, so all these concepts you will know. Okay, Then I read, I put whatever the value I read, I divide by 1024. Okay, so I divide. So just know, right? Don't. So why you are doing this, sir? If you ask, I cannot answer now. But you know, okay, just this is an idea. So if I do temp is equals to, okay, then I need to do temp into 5. Okay, temp into 5 volts. Okay, then what I need to do? I need to do temp is equals to, okay, I need to subtract the offset. Okay, 0.5. This is one thing. Sorry, temp minus 0.5. Okay, then I need to do, okay, temp is equals to, okay, temp into 100. Okay, then finally I print the temp value. Okay, then this temp value will exactly show the, okay, whatever the temp. So what I mean by this is, so in this case, directly if I read that corresponding value, that environmental temperature is not shown, it is showing some other value. So to make that temperature, okay, shown, I need to do certain computations. Okay, so here you need to understand about DA, all these things. But anyway, the computation is just I read that value, then I perform division with 1024. Okay, so then that after division and I multiply that value with 5, then I subtract with minus 0.5, then I multiply with 100. Okay, after doing that computation, I get exactly what is the temperature is there. That temperature is shown in the serial monitor. Okay, so just see this. If I try to simulate this code, okay, so sorry, okay, okay, so now you see the serial monitor. Okay, so you are getting 24.71. What is the reading? So 20 for 25 degrees, you are getting the exact value 24.71, right? Now if I increase for 53, okay, for 53, okay, of course exact value you are getting 54. Okay, 54. Now you can see, right, exact value I'm getting, right? So now if I increase the temperature, for example 69 degrees it is showing here, it is showing 68.65, right or not? So what I mean by that is, so definitely if you interface some sensor, directly you will not get the exact value. For getting the exact value, you need to do certain other things. Maybe you need to apply certain formulas. You need to apply certain formula to get that exact value. Okay, for example, if I get 125, so exactly 124.80 exact value are getting. Okay, if I get to minus to 40, you're getting minus 40.23. Some mistakes will be there, some errors, some offset errors will be there. Okay, so in this case, the computation is just, this is a computation. After reading that value, I need to, okay, perform division with 1024, then multiply with 5. Okay, then I subtract that offset, okay, which is a 0.5, then I multiply with 100, I get exact temperature reading. Okay, for 20 degrees I'm getting 19.82. okay, so this is the reading, right? This is where the temp value, I'm getting the temperature value. So here just I'm displaying the temperature value, Babu. But what in the real scenario, what you can do, so now this temperature is 35.94, right? You are getting the temperature, right? Now we can write a condition here. So if temperature is greater than 30 degrees, okay, you can turn on the motor. You can also interface a motor here. Okay, so if temperature is greater than 30 degrees, you can turn on the motor. So that things, such a simulation we'll see tomorrow. Okay, so okay, Nana, so this is a basic idea, right? Basic starting behind the IoT. So definitely IoT is supported, right? IoT is, you are making a thing intelligent, okay, and you're connecting that thing to internet. So for connecting such a things, you require you require this support. You can add intelligence using such a board. Such a board is support. Okay, such a board has a microcontroller, okay, which is an intelligent part. So in that microcontroller, not only microcontroller, you can interface various sensors. Like in this case, I interface temperature sensor. Previously, I interfaced LED like potentiometer. Like you can interface motors, you can interface different things, right? So so based on that circuits, okay, you can write, okay, so some interfacing logic will be there. So which pin to interface, for example, if I want to do, okay, if I want to interface some PWM, pulse width modulation is there required, or whether serial communication is required, or I require I2C. Okay, so all such things I can look into that interfacing circuit. Okay, after knowing that interfacing circuit, corresponding interfacing circuit, I can interface the hardware. Okay, after interfacing to this hardware, Okay, I have a processor, I have a sensors, I have a actuators, everything, you know, right? Which pin it has interfaced, which interface you have used, whether it is I2C, whether SPI, whether UART, whatever the techniques. Okay, so after knowing all those things, you can go to the software part. Okay, by knowing all these interfacing things, go to, you know, right? Here I should know, right? A0. I interfaced this sensor A0. Then only I can write this, right? Then only I can write this analog read of A0, like that. So you should know all the hardware, then only you can go to the software and you can write. Okay, you can write the necessary software and you can control, right? So this is just a embedded part. Okay, now the next part is what you need to connect this to a internet. Okay, that you can do in two ways. What you can do is you can connect this via Bluetooth to your mobile phone. You can mobile phone, you can connect to the internet, like that you can do, or you can connect this to Raspberry Pi via Bluetooth. Okay, and Raspberry Pi you can connect to the internet, or what you can do, you can directly connect a Ethernet shield to the Arduino and you can directly connect this to internet. Okay, so so that ideas, all these ideas you'll understand. So this is the starting day. So these are the few simulations I want to show. Like this is a Tinkercad. Okay, Babu, if you search for internet, right, if you want to do whatever it may be, Tinkercad designs are available in YouTube. Also many videos are there regarding this Tinkercad. Okay, so you can have the idea, like any ultrasonic distance, okay, intrusion detection, whatever it may be, or any gas leakage, home automation project, or any automobile based any dashboard you want to design. Okay, or any brake control. So based on whatever the idea it may be. Okay, any COVID based projects now. Okay, so you want to design any social distancing for project, or okay, you want to design any project for okay, social distancing, or any other, many issues are there, right? Any this patient monitoring. Okay, some patients are there in a isolation ward. Okay, so for them what you can do with IoT, like that, right? You can think of, right? But whatever you think, you should think in the context of sensor. Okay, I want to make that, okay, automated. For that, which sensor I need to use? Okay, if I want to control something, I need to use actuator. So what actuator I need to use? So whether that is available in the market or not. If available, how many are available? Which is feasible one? So first of all, you should decide in this. Okay, in this way you should think of. Okay, so what to use? Whether Arduino I need to use, whether I go for ESP. Okay, or in Arduino, what kind of Arduino I can use? Okay, different Arduinos are there, or directly I can go for Raspberry Pi. Okay, or I can use any other thing, like that. You can think. This is a thought process. Okay, so okay, Babu. So with this again, I'll continue. Okay, I'll continue the further things. Okay, so okay, Babu. So this is the architecture flow of IoT. Okay, Babu. Whatever may be the thing in IoT. Okay, so that will start with the sensors and actuators. Okay, so such an embedded board. Okay, so then okay, for example, you may think like that. Okay, so so here only one temperature sensor is there, right? So here only one temperature sensor is there. Okay, so for example, in our VNR college, okay, there are some 10 server rooms are there, for example. Okay, for example, D block, okay, 5 server rooms. So D block server room is there. Okay, and C block server room is there, A block, like that. 5 blocks are there, 5 blocks, 5 different server rooms are there. Now in 5 different server rooms, what I need to do, I need to deploy this such a device to monitor the temperature, for example. Okay, so in such a case, how many such boards I require? So in each and every room I need to deploy one board, right? So 5 boards are there. Okay, now how to do that? That 5 boards, what I need to do, I need to connect to a gateway. Okay, that for example, I can have a gateway somewhere somewhere which is in the middle to all that rooms. Okay, for example, okay, near some mechanical block I can have a server room. Okay, sorry, I can have a gateway, for example. Okay, so now what I'll do, I'll not connect all these devices directly to the internet. What I do, I'll connect, okay, server room 1, server room 2, server room 3, all these 5 server rooms to this gateway. Now I connect only the gateway to the internet, right or not? So what I can do is, rather than connecting everything to the internet, I can connect, okay, I can connect them, okay, I can connect them to a gateway. I can do some local processing, then I can transfer some relevant data to the internet, right or not? I cannot push everything to the internet. That is not required, right? So that is called this, okay, local processing. Okay, I can do some local processing. Okay, everything is no need to dump to the internet, right? So some relevant data which is there, that relevant data only I can dump to the internet. Okay, so irrelevant data no need to send to the internet, right? That is the thing here. Then I can have a local storage, so local processing, local storage, right? Then I can have a network. Now this local, whatever all the sensors, okay, 5 server room sensors are connected to this local, okay, local device gateway. Then I can network it, I can connect to the internet. Okay, then cloud, I can do cloud processing, okay, internet. Okay, so I can have a cloud processing, cloud storage, I can perform analytics, I can perform machine learning, I can perform deep learning, that artificial intelligence. Okay, so I can do all the intelligent algorithms in the cloud. Okay, then I can have a mobile applications. Okay, so basically this is the flow, Nana. So in this sense only we have, okay, our committee, like whatever the IoT committee has included the classes. So mostly in the coming 2-3 lectures you will be talking about sensors, and of course the next lecture I will talk about what are the different sensors are there, what are the different ideas you can get, different actuators are there. Okay, what is sensor, what is actuator, starting from the definitions. Okay, we'll see in the next class. After that you talk about the microprocessor, microcontroller. So definitely, okay, this is a embedded system, whatever I call this, okay, whatever I have designed now, okay, whatever I have designed now, this is an embedded system. So that's what embedded system is plays a major role in case of IoT. Okay, so then we have 1 hour talk on embedded system. Okay, after that what we do, after that you go for this networking part. Okay, so what are the different, how to connect this, okay, so networking 2 issues again comes. So for example, see here I have a 5 sensors are there, 5 sensors are connected to the gateway via Bluetooth. So local networking will be there, so also global networking will be there, like connecting to the internet, Wi-Fi. Okay, like local internet, local networking, for example, LoRaWAN, okay, or Bluetooth or Zigbee, such protocols will come. Or if so, for example, you see that RoboCinema. Okay, what RoboCinema is there? That robo will be sitting outside that hospital. Sana will be writing exam, right or not? So using Zigbee protocol, they both communicate. Okay, that fellow will talk and she will have some headphone. So that is a local connectivity. That is not a, okay. So just some meters will be there, some meter distance, right? So that is a Zigbee protocol, or Bluetooth we can use, right? Or Bluetooth low energy. Like that, many protocols will come to connectivity. Also, internet, we want to connect to internet, right? For example, you want to connect to the cloud. So that protocols are different again. You'll get MQTT, COAP. Okay. So also you get in the local connectivity, you get this wireless sensor network. So wireless sensor network protocols. So all these issues will come. So we go for networking. So networking, after networking, okay, we go for the, okay, cloud processing. After cloud computing, what we do? So after cloud computing, we go for this again boards. Okay, these boards. Okay, so finally you learn about how to coding this Arduino. Okay, starting from Arduino, going to ESP. Okay, okay, Node MCU, that ESP board, Node MCU board. So that has a Wi-Fi, directly Wi-Fi in that board. Okay, then you go for Raspberry Pi. So all these boards you learn, right or not? So then, okay, this is what the training objective. Okay, so all the training objective is provided in the form of layers here. Okay, that's what IoT is. Okay, so okay, Nana. So these are the basic sensors. Okay, anyway, tomorrow we have a separate talk on sensors. Okay, sensors and actuators. I will also show some simulations of how to interface sensors in the next session. Okay, so we'll see what is sensors. Okay, you can see here. So different sensors are there. Like, okay, so temperature sensors, proximity, pressure, water quality. Okay, so gas sensors, smoke. So all these sensors, different sensors are there. So the talk, what is sensor, the technical, okay, technicality of behind the sensors. So how this works. So all this stuff we'll study in the next session. Okay, so that will be handled by me next session, 1.5 hours. In that session, I will tell about the sensors. Okay, so this is what, right? So okay, so anyway, it's already 1 o'clock. I can understand you have 140. There will be one, okay, classes for you. Okay, so this is the today's agenda, Nana. See what I told. Just a recap of just 2-3 minutes. Just see this. Okay, so just understood what is a thing in IoT. Okay, see what is a thing in IoT. Then we know that, okay, we can add a computational intelligence to this IoT. Also, if we can add a networking to this okay, to this thing, then we can get a thing. So this is what a thing in IoT. So such a things, many things are connected, billions of things are connected in the internet, like okay, all your smart watches, your shoes, smart shoes, your tables in a college or server rooms, whatever it may be, cars, okay, all this stuff, your bulbs, okay, all these things are connected to a single network, right? So okay, so now this is a traditional example, traditional refrigerator. Then we can add an intelligent refrigerator by adding embedded sensors and actuators. Then if we can also add connectivity, okay, so we can get, this is what IoT is all about. So here I told one point. What point I told is, whenever you are tackling any IoT project, you make sense. So make have some sense that, okay, whether IoT is required, whether the internet connectivity is required. So if I use internet connectivity, what extra advantage I'm going to get? Okay, that point you need to extract in each and every project. Okay, so then this is another example of connecting a chair, okay, adding computational intelligence as well as connectivity to this chair. Okay, so these are some statistics I shown why the IoT is very important. So IoT along with IoT, artificial intelligence, so big data analytics, so this forms the fourth revolution, okay, fourth industrial revolution. Okay, so we understood the definition of IoT, okay, some first IoT device. Okay, not only we in this we can say do that. See nowadays, okay, you know or not, even humans human can be a thing. Okay, we are also maybe a thing. Okay, like that cattle is a thing. Like we as a humans also, we also one of the maybe future we may be connected to internet. Maybe you may have some you will be connected to internet, right or not? So that is also happening now. Research is happening, right or not? So okay, so these are some technological transformations because of these technologies. Okay, then we have started with Arduino Uno. Okay, this is one basic platform which is initially used okay, by IoT developers to start okay, designing these IoT products. Okay, so for this, just we have used we know that we just understood that there is one platform called Tinkercad. So in this Tinkercad, okay, without having actual hardware, I can directly put my idea, whatever the idea I have, then I can start coding and I can check the simulation here. Okay, so if this works, this simulation works, then I can go for the physical design. Okay, so also remember that this simulation works only for this thing. We cannot have any connectivity. I cannot connect this to any mobile phone. I cannot do that. Okay, so that thing I can do embedded, whatever the embedded like connecting sensors and writing this code. Okay, this I can do. Okay, Babu. So here we have first interfaced LED, then we have interfaced that is output, then we have interfaced a potentiometer, then we have interface one sensor, temperature sensor. So we understood that directly whatever we read that value, that may not be exact value. For getting the exact value, we need to do certain computations. Okay, so with this understanding, I want to wind up the today's session. Okay, so next class will be talking about what are the different sensors are available. Basically, what is a sensor, what is actuator, what are the different sensors are there, and we'll do some Tinkercad simulations regarding few sensor interfacing. Okay, so that is the, so with this I'm winding the class. Okay.